This is question number 11 of homework 4. If it were unlevered, the overall firm beta for wired widgets incorporation would be 1.5. So this first sentence tells us basically the beta asset, the asset beta or beta 0. So that's the equity beta when the firm doesn't have any debt. So when it's unlevered, the firm beta, that's the equity beta, because now the firm doesn't have any debt. Hence, all the firm value is equity value. Hence, the firm beta is also the equity beta. And under that situation, equity beta is the unlevered equity beta. So it's 1.5. So then why don't I just beta 0, 1.5. Copy that number in my Excel sheet. So later I can just directly use that information. And WWI, Wired Widgets Incorporation, that's short for that, has a target debt equity ratio of 0.4. So D over E, the target is 0.4. And this sentence can tell us how to figure out D over D plus E. As I explained in another video for question 10, number 10, we can just directly use that by assuming D equals 0.4. Hence, E must be equal 1. So we can just plug that into the calculation here to figure out D over D plus E. So once we know the D over D plus E, we can also figure out E over D plus E. And that's simply 1 minus this. Debt value ratio, hence equity value ratio is 1 minus the debt value ratio. And then continue. The expected return on the market is 0.09. So RM, it's 0.09. And the next sentence, and treasury bills are currently selling to yield 0.06. And in class, we talk about, if you can find that from my PowerPoint lecture slides. Generally, we proxy the risk-free asset by treasury bills. So this sentence tells us basically what is the return on the risk-free asset. So that's the RF, 0.06. And WWI 1-year bonds with a face value of $1,000 carry an annual coupon of 7% and are selling for $976.56. So this sentence tells us how to calculate basically the yield, basically the cost of debt. Because what happens is this bond only has 1 year. So this is current time point, and this is 1 year later, 0.1. So this is a 1-year bond. And the price today, you pay this price. Price today is 9. This is P. P0. That equals 976.56. So a bondholder, a bond investor can pay this price and buy a bond. And once he holds the bond, he is entitled to the future cash flows of this bond. And what are the future cash flows? 2. First, the coupon, right? The coupon. So this is a 1-year bond. So he can only be paid for one coupon. And we know the coupon rate. So we can just multiply the coupon rate by the face value to get the coupon payment. So this is a 70. 7% times 1,000, 70. And in addition to this, he is also entitled to the face value or the par value, right? Face value is par value, same. That equals 1,000. So he's entitled to these two cash flows. And then the question is, what is the return? So in general, to figure out the return, or what we call the yield to maturity, is a complicated calculation. We have to use either a financial calculator or Excel. But in this case, actually, because this is only 1-year bond, so the cash flows and a very only two cash flows, so we can calculate the yield without much difficulty. We can just because the meaning of the yield is that it makes the price to be equal to the present value of all future cash flows. So writing that down as a mathematical expression, the price equals present value of all future cash flows. So the face value, in this case 1,000, right? All future cash flows means the face value plus the coupon. Sorry for my ugly handwriting because I'm basically using the mouse rather than a pad or pen to write this down. So bear with me for a moment. So 1,000 plus the coupon, and because this is 1 year later, so we have to discount that back. That's what we call the present value, right? The present value. So it's discount at this cost of debt, RD. And then we can figure out from that we can calculate RD. RD is simply you just change sides, right? 1 plus RD must be equal to 1,000 plus 70 divided by P0. Hence, we write down one more step. 1,000 plus 70 divided by P0, that's 976.5956. Yeah. Hence, RD is simply this whole chunk here. Just directly copy that and minus 1. Right, so that we can solve out this cost of debt without too much trouble. And that's actually the first part of this question, solving out the before tax cost of debt. And basically what we did is the before tax cost of debt. So I can just directly input that number into my sheet, the spreadsheet. So RD, based on what we did, equals 1,000 why don't I write down one more step? Coupon rate 7%, and coupon must be equal to the face value times the coupon rate. Hence, RD must equal to the face value plus the coupon over price today. Oh, I have to write down one more input. That's the price. P0, 976.56. And so now we can write down this face value plus coupon divided by P0, and don't forget about -1. So this gives me, going back, this is in percentage terms, so I can change this to be in percentage. Change this to be, this gives me 9.57%. 9.57. And part B, WWI's cost of equity. So how can we figure out the cost of equity? We actually know the cost of equity when the firm doesn't have any debt, right? This is the first sentence. It's unlevered equity. So this cost of equity here means that if the firm does have debt, and that's the real situation here, because we know the target debt equity ratio. And then what's the cost of levered equity? Again, we can use our this equation. You can find the equation from my PowerPoint lecture slides. This is beta 0. That's basically the first sentence. This is a 1.5 is beta 0. Beta 0 equals debt value ratio times debt beta plus equity value ratio. Debt value ratio, equity value ratio, we just did that calculation, right? Based on the debt equity ratio, we did that calculation for the debt value ratio and equity value ratio. As we know these two numbers, and we can also figure out this debt beta of debt. How? Because we know the RD, and we know the relationship between RD and beta. That's based on a campaign, right? RD, let me write down here, write down in my OneNote pen. Oh. And based on the campaign, CAPM, capital asset pricing model, RD equals RF plus beta D over or times RM minus RF. So then we can back up. We can back out this beta D by solving this equation here. So beta D must be equal to, moving this RF to the other side. So this becomes RD minus RF, and then we divide both sides by this RM minus RF. RF, RM minus RF. So that's how we can figure out this beta D. Okay, so let me just do that calculation first. Beta D That's RD minus risk-free rate right here, 6%, divided by RM, market return, minus risk-free rate. So this is beta D. And then we can use this equation to figure out the equity beta. And then once we know the equity beta, we can also figure out the cost of equity using CAPM. So that's how we do that. So how can we solve this beta equity? We can just move this whole chunk to the other side. So the right-hand side will just simply become the equity value ratio times the equity beta. And then we can divide both sides by this equity value ratio, then we can solve out this equity beta. So that's the step we can do. So let me write down more steps so you can understand this more clear. So beta 0 equals D over D plus E times beta D plus E equity value ratio times beta E. So what I want to do is to first move this first term to the other side. Hence, the right-hand side, let me move the switch sides. So the right-hand side will become now the left-hand side after switching sides, E over D plus E times beta E. And that equals beta 0 minus, once I move that to the other side, I have to change sign, D over D plus E times beta D. So, and then once we do that, we divide both sides by this E over D plus E. Then we can solve out this beta E. So this becomes beta 0 minus D over debt value ratio times beta D, equity debt beta, divided by E over equity value ratio. So we can figure out this beta equity here. And then the rest of the job is to plug in the numbers. So beta equity equals unlevered equity beta, that's the first 1.5, minus the debt value ratio, so that's right here, times beta debt over equity value ratio right here. So that gives me the levered equity beta. Once we know the equity beta, we can use CAPM again to figure out RE, the cost of equity. So that's simply RF equals RF plus beta times RM minus RF. So this is the, again, we can change this format to be percentage and then keep 2 decimal places, rounding requirement. So this is the cost of equity, 10.87. And finally, once we know the cost of debt and the cost of equity, we can figure out the weighted average cost of capital. And we have to know the tax rate, right? The tax rate. The TC is 30%. So this WACC, RWACC, weighted average cost of capital, is the debt value ratio times after tax cost of debt, 1 minus the tax rate, times cost of debt right here, plus equity value ratio times the cost of equity. So again, change the format to be in percentage term and keep 2 decimal places, 9.68. 9.68. All right, so now let me check my answer. Okay, we got every answer right. So this is another question of basically, even though we don't have a comparable firm here, but we have to do the basically relevering because we know the unlevered equity beta, but we don't know the equity beta under the firm's current capital structure or target capital structure. So we have to do the relever based on the unlevered equity beta, and then we can figure out the cost of debt and cost of equity under the target capital structure, and then we can figure out the weighted average cost of capital.